started. So, Mr. John Nance, sir, the floor is yours, and good luck today in the discussion. Thanks for joining, everyone.
Thank you, David. Everybody, I'd like to thank you guys for taking your time today for joining us on this, as Dave Bell said. What we're seeing on our screen right now is how a DE-4000 would look if we were simply to take a control board and a one terminal board and hook it up and power it up. This is what we would see by default at first. And so what I thought that I would do today is to put this in some perspective and to show you the basics of the software. We've got 2 hours, is my understanding. I figured that what we would do is we would model what we do today around one particular drawing. And I've selected the next generation. For those of you who are familiar with the term, the DE-3000 flex panel, I chose today to select the DE-4000 flex panel design that is coming up. And for our driver, we'll model it after a Caterpillar Atom 3 3500 engine. So I think it'll help put this all into context as far as helping to connect the dots. So I'm hoping my theory is correct here. So what we're going to do is we're going to set up some channels first. And so I have a 2-part drawing. I have a 5900-flex panel drawing, and then I have a interface page or an interface drawing that covers the engine. So I'm going to open that up real quick. And right off the bat, and I'm not going to do every one of these, and I may make some channel shifts just based on the lab unit that I'm connected to. But I wanted just to go through and do some short examples of how we're going to set up some of these channels. So we'll start out with suction pressure on channel 1, and I'll dot back to the software. And again, this is not really software. It's software that's built into the 4000. So I'm just simply using a web browser and connected to my hardware. And what I'm going to do is I'm going to go into the channel section, and we can see I have terminal board number 1 selected at the top and input channel 1 selected. Well, this is a really neat feature. If I'm just going to click right up here at the top, and it gives me what I call, I don't think I've heard a name from any of the software developers, but I call this my channel grid layout. And it kind of works. And I'm going to just simply click on channel 1, and it's going to take me into the details for channel 1. Of course, not much going on there right now. And so the first thing I'm going to do is I'm going to toggle back over and look at that interface page, and we can see channel 1 is going to be suction pressure. It's a 0 to 5 or 0.5 to 4.5 standard ultronic pressure transducer, and its range is 0 to 1000. And it's specified in the drawing as a Class C shutdown for the low and a Class A shutdown for the high. So we're going to set that up real quick. I'm going to click the Not Configured drop-down arrow, and we'll find pressure. And we're going to select the range as 0 to 1000 from the drop-down menu. Units, PSIG is correct. Decimal places. Well, this is kind of a high-pressure transducer, so I'm going to say 0 decimal places. So I'm going to leave that as default. Filter time. So filter time, based on what I've seen with the 4000 right now, different filters on different channels work different, and I'll cover each one as we go through them. But filter time is an electronic way for an analog pressure transducer to keep it from bouncing around a little bit. You know, there might be a little pulsation or a sudden pressure change. This is just a way to kind of filter some of those sudden changes out in what we see and view. And with a lot of the pressures, I've been reducing that down to about 0.6 seconds to 1 second on the programs that I have been writing. I'm going to go on and click Save at this point. Notice each time I change a field on this screen, it turns yellow, indicating that I need to save it. So I'm going to click Save real quick. And before I go too much further, I'm going to go on and name this channel. I'm just going to simply name it suction. I think we'll be able to determine that it's pressure at a later date once we build the dashboard. And at this point, I can set my high and low safety shutdown set points. So for today's demonstration, we'll use a low shutdown point of 100 PSI. We'll use a high shutdown point of 250 PSI. The high input class will be a class A, hence always active. And the low set point, we're going to make a class C to match our drawing. And for those of you who are real familiar with the DE-4000, you'll know that the class C does work as the industry standard, meaning when the fault condition clears, that channel becomes active. But in case the fault condition, for some reason, something catastrophically goes wrong and it never clears, we do have an expiration timer. Well, on the 3000, we had a global timer for all Class C channels. The default on it was 10 minutes. In the 4000, each Class C channel can have its independent expiration timer. The channel, again, still becomes active once the fault condition clears or when the timer expires, whichever becomes first. I'm going to go on and use a default of 600 seconds, which would equal 10 minutes if I did my math right. And that's pretty much it. Now we can see already, now that I've activated the channel, that it's reading 416 PSI up in the top right-hand corner. I don't know if you can see where I have my mouse pointer at. I'm going to see if I can't make an adjustment on that and drop that down. But I dropped it down a little too far. Great. We'll just let it float right there. That'll at least keep us from faulting out. So what I want to do next is set up the other details of this channel. Now by the drawing, in the channel interface page and my lookup table, I'm not really doing anything with it, but I do want to go on and set up some warnings. So I'll jump back and I'll go to page down, and you can see that this is where, if I wanted to have a control strategy or turn on a digital output, this is where I could select the values, and I could select one of the 8 digital outputs that's located on the terminal board. And again, from the hardware section we covered a few weeks ago, these outputs are now not just syncing, but they can also be sourcing, meaning they can turn on and off either a ground signal or a positive voltage signal. We'll keep this as not used for right now, but I want to set an alarm setting. So the high, I'll set up an alarm of 225 pounds, and for the low alarm set point, I'll use 125 for today's example. Right through here is the advanced section. It shows the standard default scaling voltage. 0.5 volts equals 0 PSI. 4.5 volts equals 1000 PSI. I'll save my changes. Now, when I first saw this, I was like, oh great, this is where we can calibrate the sensor. And I suppose that we can tweak the sensor if we need to at the low and the high. But the development engineers have told me if we want to calibrate the system, the ideal way is simply to select this calibration button. So currently, if I had a true pressure transducer hooked to this simulator that I have, and I was reading atmospheric pressure, and let's say maybe it was reading 1 or 2 pounds when it should be reading 0, I could simply change this value to 0, push enter, which I won't do it right now, and then click calibrate. and it would zero my gauge out for me, or zero the pressure transducer out. We had a subject earlier this week going on out in the field, and so I thought that I'd show y'all that while we were setting up this channel. So normally what I would do is would just simply select next channel down here at the bottom to go to channel 2. But to save a little time, I'm going to click back on my channel grid view and select another different channel at random. We won't set up all the channels for this today. So I think the next thing we'll do is we'll select a discrete channel, and we'll probably do 2 of them real quick. We'll go on and do channel 7, which is a scrubber, high liquid level, digital input, rig set up as a normally closed, class A. I'll simply click on channel 7. And we'll select discrete. And we'll tell it that it's a normally closed switch. Now, the filter time on what I've seen on the discretes works almost like a slight little debounce timer. So if it's a very, very critical shutdown, such as high liquid level and a suction scrubber is, I'm going to select the lowest time possible. In this case, 0.2 seconds. Disregard the low gauge range and the high gauge range. I'm going to set the class as a class A. And there are still high points and low set points and digital outputs that we can select. And believe it or not, they can be used. We'll cover more of this in the advanced section in details. Alarm settings. We can set alarm settings, but honestly today, right now, I couldn't tell you if that has much relevance for a discrete channel. We're going to go back up to the first page, and we are going to go on and name it. And it does give us quite a bit of character spacing that we can put in for the name, which I find very nice. Although sometimes that can come back and bite us later. And let's do a lubricator no flow. There's a lot of fun things. And this one says channel 27 and 28. My demo is I have a simulator for this wired into channel 30. So I'm going to fudge the demonstration just a little bit and jump straight to channel 30. We're going to call this a discrete. I'm going to call it a normally closed. I'll go on and name it. We'll name it Lube No Flow. I'm going to keep my filter time set very low. In this case, I'm not using a true no-flow switch, but I'm planning on using a proximity switch. And so what we want to do is we want to do an average time or be able to see the cycle time between a full lubrication cycle. So we don't want it to shut down when this switch or input changes state. So what we're going to do is we're going to select none for the channel class, and that will keep this channel from being able to really shut the unit down, but we'll make a change elsewhere in the program to take advantage of this channel. And notice too, each time I change the sensor type or the channel type here, that it changes in the top right hand corner. It shows us what the dip switch settings should be on the terminal board for the DE-4000. And here too, we can see, I don't know if you just caught that, but we can see that my timer relay is definitely cycling and changing the state of this channel for us. So we know that it's already working. Let's do a temperature next. We'll capture channel 20 for cylinder temperature 1. It's set up as a K-type thermocouple. The low shutdown is going to be disabled, but the high shutdown will be a Class A. So we'll simply select temperature. K-type thermocouple comes up as a default. I want to look at it in a unit of Fahrenheit. I don't want decimal places. Now, this is something else on the filters. We all know that thermocouples are kind of slightly sometimes susceptible to noises. And so what I like to do is give these a little bit of a high filter. We could have, in the real world case, we could have something go from 0 to 2000 PSI in a split second. But in anything that I've ever had experience with, we're not going to go from 100 degrees to 400 degrees in a split second. Everything takes time to heat up. So I like to have large filters on my thermocouples. I have been using 28 seconds in all my field endeavors with the 4000, and I've been having really good luck with this filter time. We can also select the gauge range. Now we can do this on any gauge, even that suction pressure that we set up earlier. Being that this is a compressor cylinder, I know that if I get up to 1200 degrees, I've really got some serious problems. So I'll have my shutdown kill set a lot lower than that. So to help the resolution of how I see and view this data, I'm going to just go on and select 350 degrees as my high gauge range. And at this point too, I'm going to go on and set a high kill of 250 degrees Fahrenheit. And I'm going to leave the low kill at negative 10,000. I'm going to keep both input classes as a Class A. I'm going to save this screen, and I'm going to name it real quick. I think everybody will understand what that means. And let's go on and give it a high alarm. Let's set an alarm at 225 degrees. And the really nice thing about this is you can change this on the fly at any time. And so I think for this application, we've covered just about every channel that we need, all the different channels that we have on this panel design. We have a pressure, we have a discrete, we have a no flow, and which is also a discrete, but a little bit of a hybrid. We're going to cover that in a few minutes. And we have a thermocouple. So another thing that I like about this one is we can also name, and we're going to jump back and forth a little bit as we set up compared to this drawing, but we can actually label our digital outputs, what they are. We can actually label what our analog outputs are, and then our engine RPM. And while we're talking about engine RPM, let's go on and set that channel up real quick. So this channel is already enabled. It's already tagged as engine RPM by default. Low gauge range is 0 to 2000. I said we would model this after a 3500, so I'll tell you what, we'll set the high gauge range at 1500, well above maximum rated RPM for that engine. And we're going to set a safety shutdown, a high safety shutdown of 1450. And we'll go on and do a high alarm at 1425. We'll back up a step. We'll do a low shutdown of 150 RPM, and we'll definitely make that a Class C. And we will give it a little bit longer on the startup time. We'll say 120 seconds, or until the fault clears, whichever comes first. Any questions so far? Okay. Well, one thing that we need to successfully do a simulation on a startup for this one would probably be compressor oil pressure too. So I tell you what, let's go on and set that up. And it should be channel 6 from my drawing. And it's a 0 to 300. We'll just run through this one real quick. I'm going to set a high gauge range of 150 pounds. We'll do a high shutdown of 120. We'll do a low shutdown of 45 PSI. And I'm going to pause right here on the channel section after I name it. I'll just put COP for compressor oil pressure. Because before I set my low shutdown point classification, I want to take you back to the main section and show you something about this, which I find actually fascinating these days. So we're going to go into the global section, and I'm going to go into system. And the first thing I'm going to do is just start at the top, and I'll work my way down. We'll just call this a DE-4000 demo. Of course, we could name it anything we wanted. Number of terminal boards, 1. HMI refresh rate in seconds. The go-to default right now has been 0.5 seconds. We go much lower than that. It seems to slow the system down more. A 0.5 second is proven to be out in the shops and in the fields a very good refresh rate as far as how fast the HMI responds to when we touch the HMI versus a reaction from it. Global alarm output. I'm going to clear this for right now. And I'm going to go on and save my changes so I don't forget. So I'm not going to use an alarm output just this point in time. A fault output. If I jump back and look at the drawing real quick, I do believe I have a fault output that I am using. And it is digital output 8. And notice this comment. It says opened when DE faulted. So likewise, it would be closed when the DE is not faulted. Now, this is something new if you're used to like the DE-2500 or the DE-3000. Because if we used digital output 8 as a fault output, it turned on or close the contact at a fault. So I'm going to go on and select for my fault output, digital output 8. Now, here's a kicker. I just selected a digital output and it's not showing anything, and there's a reason for that. So I'm going to push enter even though I hadn't selected anything to exit back out of that. And then real quick, I'm just going to jump back to the channel section. I'm going to jump back to grid. I'm going to select digital output 8, and I'm going to give it a name. We'll call it fault status for right now. Now, once I've given that name, if I jump back to the global section in the system, now if I come back to where we left off, fault output, digital output, there's that fault. There's that digital output channel. So I just simply select it and say enter, and it's there. Now, here's a nice option. Invert output, energized when not faulted. So to match that of the drawing design, I check that box. I'll go and save these changes. Primary RPM input is already set up. I already set that channel up or set some of the details up in that channel. We're going to go back to it as well. Timer settings. This is one of my favorite things about the 4000. So what we're going to answer right here, the software says it's only the B timers, but it's actually the C timers too. So when do the timers start counting? So we as the user or the programmer that's setting up the system get to select that. So we can tell it to start counting down when the crank cycle starts. We can tell it when the start button is pressed, or we can tell it when we exceed the B timer RPM. Now this is a huge one for me, and this has been my go-to default on all of the projects that I've been working on. What I'm going to do is I'm going to tell it an RPM block that pops up once I select that option. I'm going to just tell it 100 RPM. So from a starting perspective, as soon as we see 100 RPM or greater, all the timers, both the B and the C, will start counting down to their expiration time. We also have test mode timer here. It's set up by default at 5 minutes. For right now, I'm just going to leave that. That might be a little bit excessive, but we have a new safety system protocol with the test timer, so 5 minutes may not be absolutely that bad. Okay, so there's a few more things that we want to bounce back to on the channel section now. Now that we understand when the C timers and when the B timers start counting down, when it sees 100 RPM, we can go back and finish our timers. So the first thing I'm going to knock out of the way is the engine RPM. We gave it a high shutdown, we gave it a low shutdown, we told the low shutdown to be a Class C, we gave it 120 seconds expiration time. We gave it a high, oh, I'm sorry, that's a control set point. I did not really mean to do that. We'll change that back to 10,000. That's what I get for going fast. We're going to page down a second time, pulses per revolution. So this is where I get to tell it if I'm using a magnetic pickup on a flywheel where I have ring gear teeth, I could tell it how many teeth are on that flywheel. Now, a 3500 is 183 teeth on that flywheel, so 183 pulses per revolution. But because I'm running a demo and I have an RPM simulator hooked to it, I'm going to leave it at 60. But I just wanted to make sure you saw that most of the channels that you run through, there's only 2 pages available to see. In the RPM, there's 3. Another thing currently right now about the RPM channel is you cannot make any safety changes to it whatsoever without, and they will not take effect until you do a full power cycle of the system. All the other channels, if I change where my compressor oil pressure is, my discharge pressure, my suction pressure kills are set at, my temperature kills set at, they take effect immediately, but not the RPM channel. Any changes you make have to be done while or once you make the changes, you have to do a power cycle before those changes will take effect. I'm not going to power cycle it just this second, but we will have to do that if we get to the point of running a simulation today. I'm going to go back to the channel section, and the last one I really wanted to look at here before we get into the no flow details is that compressor oil pressure. I wanted to point out some things. No matter what we do, despite what we do in our best intent on startup situations, there's always certain times where somebody says, you know, it's really cold and my unit's going to take a lot longer to warm up. Well, maybe I have all my process pressure channels set up to where they're Class C's for my low process pressure kills, but they're set all up at 600 seconds, 10 minutes. But let's say I had a unit that I can't load it, and therefore I can't get those units off their those channels off their low kill points before that 10 minutes because the system's very, very cold. And what we've done in the past with a lot of systems is we simply push the reset button while it's running to reactivate those Class C timers. Well, what that reset button does is also it reactivates all the B timers. So knowing that, and now also think about what we just did under the global section for the system, where we selected when do our B timers and C timers start counting down. They start counting down the minute this system sees RPM, 100 RPM in our case. So what we're going to do is I'm going to show you two different methods and tell you why I like to use one over the other these days with the 4000. The traditional one would be to set it up as a Class B. Well, I could set it up in this case for 15 seconds. And I'm perfectly legal right there. Now, if I have an extended situation where, for whatever reason, once the unit's up and running, and I'm fixing to time out on a low process pressure, but I don't want it to shut down, I can push the reset button while it's running to reinstitute those timers. But I'll also reinstitute this timer, and for 15 seconds. Now, maybe I've been running for 30 minutes already, and this is the second or third time I've pushed this reset button. But every time I push reset, it's going to reinstitute this 15-second timer. So there's one way that we can avoid that. I can actually select it as a Class C and keep it at a 15-second timer. Still works just like a Class B, but one difference. If I'm already operating and the channel is above 45 PSI, as soon as I push reset from an idle warm-up state, this channel will not become active again because the operating pressure is already above my low kill set point. So all of a sudden, we've got a really cool feature that enhances our protection level. As long as you know how to use it, it's safe to use this way. Any questions before I move on? Okay, great. We're going to go back to the global section.
Hey, John.
Yes, sir.
This is Mike. Hey, just a quick question over the filter. Now, that's
Yes, sir.
filtering the display number on what you're watching. Does it also filter the shutdown? So if I have a noisy transducer picking up maybe some ignition noise or something, and I've got such a big, and I have a pretty big filter on it, so my numbers aren't jumping around on the display, could that still trigger a shutdown that I wouldn't see on the display?
Mike, that is my understanding and experience. That's what I have been observing and testing in labs as well as out in the field. So, yes. One thing that I talked about with a group of gentlemen was, say they had a little bit of turbulence in a surge tank up on top of a cooler section for where we were monitoring like a low level water level shutdown, and maybe the float was bouncing a little bit. That's on a discrete channel. That's an excellent way to kind of put a debounce in there.
Okay, so if it does,
if you need to.
So if the filter may filter out some of the artificial noise coming in, so it won't have all these little shutdowns that you never see, possibly.
Right. Well, I think if we've been in this business long enough too, we've all seen suction scrubbers that are getting filled up full of foam that happens to have just the right buoyancy to where it can float the float.
Okay.
So you're getting shut down because of foam, not true liquid levels, right?
Okay.
So yes, it has its advantage. Now, that subject matter may change, but based on my interviews with the software development team and my experience with what I've seen in the field and what I've tested so far in the field, that is correct.
Okay, thanks.
Yes, sir. Thanks for the question. So what we're going to do now is we're going to go into global, and I'm going to jump down. There's lots of stuff under global going on. We're going to try to cover as many as we can today, but Lube No Flow is the most important one. So earlier I set up one channel, and I believe it was channel 30 as a Lube No Flow. And remember, we told it none for the safety shutdown class channel classification. The reason being is because we're going to use a proximity switch. It's going to be constantly going opened and closed. So under global, we have this Lube No Flow section. So what I'm going to do is I have 2 Lube No Flow channels by default. Now, more can be added if somebody has more, a need for more than 2. But I'm going to just select Lube No Flow number 1. And I'm going to come down and select channel 30, Lube No Flow, and click enter. And here's where I'm going to tell it when I want to shut down. And I'm going to say 60 seconds. So what this is saying is, if I don't see a fault, or if I don't see a cycle with my proximity switch within 60 seconds, once it's up and running, this unit will shut down on Lube No Flow. Now, when we get into the advanced section, I hope to show you a little bit more things that we can do with Lube No Flow, but for today, we're going to keep it really basic and really simple. So we've set up quite a bit of channels, enough to simulate a run if we need to. And the next thing we would need to do is we would need to kind of set up a startup sequencing. And so that's exactly where we're going to go to right now. And I tell you what, before we do this, I think it's important to set some labels. So we'll go back to global. I apologize for jumping around. We've covered systems. Network we'll skip over for right now. PID we'll skip over. DS outputs. Okay, this is the real critical one. So remember, we had on the 3000 and 2500 world, we had the power supply module that had 4 output modules that we use for our primary startup sequencing. On the DE-4000, we have a control board, and because the outputs are not bolt-on modules, they're built in, an integral part of the component, they've changed the name to DS. And what we're going to do is we're going to bounce back to the drawing real quick, and we're going to look at what DS outputs do I have to use to make this unit run. And I can see on the main engine interface page, I'm using DS1 for my driven equipment ready signal into this Caterpillar 3500, and I'm using DS2 for my start signal. If I jump to the main body of the drawing, I'll zoom in so you guys can see it a little better. In this particular case, I'm going to use DS4 for a preloop for the compressor. Now remember, the engine on a smart engine has its own engine preloop cycle controlled by the engine system. We're going to use DS3 as a gas start valve. Now, we're not controlling the starter, but we're going to control what they call a skid safety valve. A lot of people, a lot of companies on these newer engines, because of fire hazards, are putting safety valves, energized to open valves for both the start gas and the fuel gas at the edge of the skid. So where the supply piping comes into from the field onto the skid, they're installing 2 valves, and it's becoming very, very common in the customers that I deal with on a regular basis. So we're going to use a digital output to control a fuel gas safety valve, a DS output 3 to control the start gas valve. So with that, let's jump back over to the software and let's label these. So 4 is already set up as preloop. Now, if we want to distinguish it, to say, well, we're not using this for an engine, we could do that right now. It's energized when running, a 0-second off delay. Now these off delays can be selected for DS outputs 2, 3, and 4. Do not exceed 10 seconds. I think one of the changes that's noted in some of our upcoming revision changes is we're going to put a limit here to where you cannot go over so many seconds. DS3 we said was going to be a start gas supply valve, like a safety valve. So we'll just call this start supply. DS2 we said was going to be we could call it a A3 start signal if we wanted to. And then we could use the beautiful driven equipment ready acronym for our signal to our engine. Now it's going to, when it comes on, it's going to come on. When it goes off, when the system faults, 0-second off delay. So we want to always make our most critical factor of how we're going to shut the unit down on DS1. In this particular application, it's the driven equipment ready signal. I'll go on and save that. There's another fun-filled fact on a shutdown that we always want that engine to lose this driven equipment ready signal first, and then at least a second delay to 2-second delay, then the start signal. So what we can do right here is go and enter in a 1-second delay off. Now these two are irrelevant because we're going to do something slightly different with them, but we're going to leave them at 0 on this page. Now, for these effects to take change, same as the RPM, I may require a power cycle. So you can see in the background, look past this saving point that's locked up on me, you can see these up and down arrows. And that's exactly what's happened. Because I made so many changes on this page, the system's requiring me to do a power cycle. So I will go and do that right now. And we're going to have to wait for the system to boot back up, and that'll take just a few moments. I apologize. If anybody has a question while we're waiting on it to boot up, right now might be a good opportunity to do so. Okay, so I've rebooted and I've refreshed my screen. We'll go right back to where we left off. We'll verify that those changes all took effect, and you'll notice that they did. If we jump back to the channel section and review our RPM channel, we can see that our changes that we had made earlier are still there. So now with the reboot, those changes are hard set into the system. So now that we've set up and labeled our DS outputs, we can jump right over to the startup section and set our primary startup sequencing. So we've got a total of 10 steps numbered 0 through 9. And if we're gonna just kind of review real quick each one of them. And again, I'm gonna keep this very simple, but ready to start, I'm not gonna do anything with this channel. I'm not gonna relabel it. I'm just gonna say, yep, it's ready to start. Warning, I don't need this section for this application. I'm trying to renumber certain things up here. What I'm simply going to do is change all the values over here in the field to 0. And what we'll do is with me changing my timer and my timeouts all to 0, we'll simply just blow through this on the startup sequencing. So almost within a blink of an eye, we'll go straight into the preloop section. Don't worry about what you're seeing up here because you're fixing to get a real good lesson on it on this next one. So preloop. So the first thing that we want to do is we want to start prelooping, right? So I'm going to turn on digital output 4 at the beginning of this state. And I'm going to hold in this state for a minimum, I'm going to say 60 seconds is how long I want to preloop this compressor for. And I'm going to give it a permissive. And in this case, what we're going to do, notice how we can say all, and it looks really busy. There's a large list, but I can just simply zero in on the pressure channels and get a smaller list, so it's easier to find what I'm seeing. I'm going to select compressor oil pressure and say enter. So what I'm saying here in this recipe is compressor oil pressure is greater than, and I get to assign it a value. And in this case, I'm going to say 10 psi, and I'm going to select save. So on this, what we're saying is once it hits the preloop state, it's going to stay here for 60 seconds regardless, but this 60-second timer won't start counting down and moving until my permissive has been satisfied. And that's a nice feature. I really like that. So now what I have to do in case I don't ever meet this permissive, if something fails on the preloop, I have to give it a timeout. Now I had to give it a greater time than 60 seconds because obviously it needs a little bit of time to build up to 10 psi, and then it needs to, once it builds up 10 psi for 60 seconds. So I have to give it a greater time. So what I'm going to do is I'm going to give it 1 minute, which is equal to 60 seconds, and 30 seconds. So I'm going to give it a total of 30 seconds more than what my timer is. Any questions on this one? So once this permissive is satisfied, and once this timer times out at 60, we will advance into the next startup sequence. Now, in this case, I had said that I had a startup valve on the skid. Let me jump back to the drawing real quick. I had said I was using DS output 3 as a start gas valve. Well, that start gas valve also controls the pressure for my preloop pump. So I kind of need to configure that, don't I? So I'm going to jump back to the warning state. I'm not going to have a permissive on this. I'm not going to have any timers on this, but I am going to turn on DS3 during the warm-up state. That's one option I could do. If I saved that, then at this state, I open up DS3, that would open up my start gas supply pressure, and then I would advance into the preloop state. There's also another thing that I could do. I could simply uncheck that for simplification purposes. And now I have the ability, and this is a newer feature, but now I have the ability, if you notice, I can turn on multiple DS outputs, and I can turn multiples off. So instead of complicating the program, I'm just going to turn on DS3 and DS4 both. So I have my supply covered, and now I also have my actual preloop pump covered. So once my preloop permissive is satisfied, and here's where I get out of order a little bit. The next thing I want to do is say, hey, you know what? I've prelooped my compressor. At this point, I'm going to say that the driven equipment is ready. So I want to go on and send the driven equipment ready signal. So I'm going to rename this state to DER. And I'm only going to hold here for 1 second. There's no permissive. My permissive has already been satisfied on the previous state, but I am going to have to turn on DS1, and I can simply save it. Now on that engine doesn't want to see a driven equipment and a start signal come in simultaneously. It wants to see a little bit of delay both on the startup procedure as well as the shutdown procedure. So what we're going to do is we're going to rename the next state ignition. We're going to rename it start. Now again, I'm going to pause here for 1 second. I don't have a timeout. I don't need a permissive. I just need to turn on DS2. So at this point, the engine's now going to have received a driven equipment ready signal and a start signal, so the engine should start pre-lubing. And then based on how it's been programmed, will run its crank cycle. Now, I don't know how long that engine's going to pre-lube for, or how long it's programmed to crank or anything, but because we have the timers for the Class B and the Class C startup, I don't need to know because I'll trigger on when I see RPM. But I can do some safeguards if I wanted to on this section. So I think what we'll do is rather than doing it on this section, we'll drop down on the next section and do that. In fact, I've already got one that's labeled crank weight. So I'll drop down to fuel and I'll rename it as not used, being that I'm totally skipping over it. 0 in all the fields. I'm not turning anything on or anything off. So it'll pretty much go straight from state 6 or state 4 straight to state 6. At this point, I'm waiting on a crank signal. I'm waiting to verify that I have a crank signal by measuring RPM. So I'm saying, hey, the RPM has to be greater than, by default, what's coming up is 400 RPM. Well, I'm going to change that to about 300 RPM. And again, because I said I don't know how long that engine's going to prelude before the starter engages, I'm going to put a high value in, but generally I usually end up finding this out before the final test run or before during the final commissioning out in the field. But I'll go on and give it a full 2 minutes. So I'm going to give it 2 minutes. If I don't see 300 RPM by the time of 2 minutes, it's going to fault out on the crank weight state. I'm not going to give it a timer up here because as soon as it sees 300 RPM, I want it to advance into the next state. I also want to do a couple of other things. Once it sees 300 RPMs, I can assume that it's up and running. So at that point, I no longer need a prelude pump running, so I can turn it off. And I no longer need start gas supply valve. And this is part of the fire safety that a lot of customers want. So I can turn that supply valve off. And now I'm going to enter into a warm-up state. Now, we can hold it in a warm-up state for 30 seconds with no permissive. And in order to set up a permissive, if I'm going to be measuring a temperature for warm-up purposes, I probably need to set a channel up real quick. So let me do that real quick. We'll jump over and we'll find our compressor oil temperature is supposed to be on channel 26. It's also a K-type thermocouple, so that won't take but a second. Did I say channel 26? I already forgot. Yes. We'll set our range. We'll go and set a high shutdown point of 190. We don't care too much about a low shutdown point. I don't really want to use a control setting to use a digital output. Maybe I'll go on and set an alarm of 180 degrees. I think that about covers it. We'll name the channel, compressor oil temperature, and we'll save that. Now you can see how the value is starting to ramp up. This channel is configured on my demo. It's probably going to go to ambient temperature in my office here. But you can see how it's not just going there instantly fast, and that's because of this filter time. So now I can jump back into the startup, and we'll go back to the the warm up, and we'll enable a permissive. And notice we can do two permissives for each one of these states. But we're going to say warm up. We're going to select compressor oil temperature. Has to be greater than, because I probably just have a jumper wire in here and don't have a way to simulate it. I'll give it a low temperature of 70 degrees Fahrenheit. And that should be enough to where we can get past it for a startup simulation. I'll jump back to the channel section real quick just to see. Must be warm in my shop today because it's showing 80 degrees or over 80 degrees. So now what we're saying is, hey, we're not going to have a timeout, meaning we can hold in this position indefinitely. The unit's running, but we're going to stay in this position indefinitely until we see an oil temperature greater than 70 degrees Fahrenheit. Now, once we see 70 degrees Fahrenheit, or if it's already started up with a oil temperature greater than 70 degrees, it's going to hold at this state for a minimum of 30 seconds. And then we move down into the running state. At the running state, I've already turned off my Preloop and my gas supply for my starter and my Preloop pump. I need DS1 and DS2 to stay on, so they'll stay on. They won't turn off. If I go back to the global, until a fault occurs. Driven equipment ready, DS1 will turn off instantly. The start signal, DS2, will turn off 1 second later. So that leaves us the cooldown section. Now, I don't want to run a cooldown timer on this application right now. So I'm going to leave these fields as 0. At a fault or a cooldown, I don't want to turn any digital outputs or any of my DS outputs on or off. They'll already take care of themselves automatically. I don't have a cooldown permissive because I'm not doing anything with the cooldown, but here's where you can find the Postloop option. So I'm going to enable the Postloop, and I'm going to select DS3. Some people's already thinking, well, wait, he's got Preloop on DS4, but my Preloop is only for the compressor. My DS3 is my start gas / Preloop gas supply pressure. And so what I want to do is I want to open this valve back up at a fault for 60 seconds so the engine can do a post-loop procedure. And other than the fuel valve, which I have not set up yet, the skid safety fuel valve, that covers the full startup sequencing. Before I move to the next part, does anybody have a question about this section? Okay, so let's look back at our drawing real quick. And we can see that we're using digital output. So not a DS output, but a digital output to control a fuel valve. In this case, like I said, this simulation, this fuel valve is a skid safety fuel valve. It's not the engine controlled fuel valve. And so all we want to do is we want to turn that fuel valve on sometime to where by the time we start cranking this engine that we have fuel on the skid, and at a fault we want to turn it off. So what we're going to do is, remember this section used to be called valves, but we found out that we could do so much more with it that we changed the name to outputs. But I'm going to add an output. And I'm going to name it fuel safety valve. I'll go and spell it all out. That might end up being too long of a name, but I can always shorten it. I'm going to select digital output 1. I'm going to say it has to be energized to open the valve. At state position 0, it will be closed, so it won't be energized. At state position, so now we have a choice of 1 through 10 positions. And the nice thing about it, because we labeled them under the startup section, what we're actually doing with them, we can see those references right through this column here. So basically, I think what I want to do is I want to open that fuel valve right when I send it a driven equipment ready signal. So here's where I'm going to open it. And I'm not going to close it until I enter the standby, aka shutdown. And I'm going to save it. And then we can see the logic here across the states. Closed, open at state 3, closed at state 10. Any questions about that one? So now that we've set up our channel section, and we've set up our system and our DS outputs, and we've set up our Lube No Flow, the next thing we can do is we can set up some dashboard screens. There's not much to set up right now, but because I hadn't configured all the channels, but I'll show you how we can see what we want to see. So I've already got RPM up here by default, and then right below it I had the DS outputs that always show up, and you can always tell a DS output from a digital output because the DS outputs have these colors to them, where if you select one of the digital outputs to look like an on-off LED, there'll be a gray icon. But I don't like where these are, so I'm just going to delete them out for right now. And what I guess I want to see on the first line is RPM, and we've got that many channels that we've selected, so I'll catch some pressures. I'll catch suction pressure real quick. To keep it unified, I'll go in and select a radial gauge and hit enter. Right next to that, I probably would normally put discharge pressure for today's exercise. We only have one other pressure set up right now, it's the pressure oil pressure, and I'll also change it to a radial gauge. Well, one thing I see right off the bat about this one is I've got a tiny little operating area, but because I have a 0 to 1,000 pound pressure transducer, I've got a lot of wasted space here, and I don't have real good resolution right here. So let's do this. I'm going to simply click on the gauge right here, and it takes me straight to that channel number. And it takes me straight to the page I want to. My gauge range, 0 to 1,000. Let's shorten that to 350. So now if I return to the dashboard, we can see all of a sudden that I have a little bit better resolution. Now I could change that again because I do show the value right here. I could also modify the low range, and I can see too I can modify the high range a little bit more I do this, how about 70 and 280? We'll do 70 for the low. We'll drop this down to 280. And this is something that can be done anytime. I've done them or let the mechanics in the field play with these systems while the unit's running. Perfectly acceptable. Now that looks great. We've got great resolution right there. We have our warning zone errors and our shutdown errors in red. So we could do the same thing with compressor oil pressure. I don't really see a reason to change the range of it, even though it's a 0 to 300. I had already set it up as 0 to 150, but we could come in and set some alarms. We could set a high alarm of 100 pounds, and we could set a low alarm of maybe 50 pounds in this case. Yeah. Now another thing is I don't like things being shifted way over to the left and dead space, or I'm sorry, way over to the right and dead space to the left. So I could just simply take that first blank icon out by clicking the delete button. I don't know, I apologize, I did that kind of quick. So now we see our gauges got a little bigger too when we did away with that to the right shift. So I'm going to go back into the editor mode here. I'm going to select the next important things. And I tell you what I'm going to do. I'm going to simply put a couple of blank lines in by pushing enter. And you can see each time I select a gauge on one line, it automatically gives me another line under it. And that's kind of handy in case I decide I want to come back in and enter something. I can always delete them. It's a little bit harder to add them in. But being that this is kind of an RPM screen with some pressures on it, maybe I want to set up a new screen and put all my temperatures in one place. I'll do just that. So I'm going to go back into the editor, and right next to this little center icon at the top, I'm going to click a plus button. And I'm going to select my temperatures. So I only have 2 right now. So I'm going to select compressor cylinder 1 temperature. And I'm going to tell it that I want it to be a linear gauge. And that's what I get. Now, if I expand this later and build the rest of the channels, I might just put cylinder 1, 2, 3, 4 across this top line. So I'll come in and drop down one line, and I'll do my last temperature, which was compressor oil temperature. And I'll also select a linear gauge. Now I can do a value. I can do a radial gauge if I want. My experience has been most of the people in the field that I'm coming in contact with like the linear gauge for temperatures. It shows a lot of nice value to it. Look back at the channels real quick and make sure I hadn't left anything out. I have a suction. I have a cylinder discharge temperature, a compressor oil temperature. How about Lube No Flow? Let's do that. Let's go back to the first page and select that on one of these blank lines I made. Now for this one, it's a virtual channel, so I'm going to select this virtual icon over here to the far right. And because I don't have many channels configured, thank goodness, it's going to be easy to find. Lubricator no flow cycle time. Notice there's a Lube No Flow timer too. I tell you what I'm going to do. I'm going to select both of them. I don't see anything else that has to do with Lube No Flow timers. And I'm going to call that good. So what the cycle time is going to show me is the time between my 2 cycles. What the Lube No Flow timer is going to do is, remember when I set the lube channel up, I told it 60 seconds. it's going to start out at 60 seconds and it's going to count down to 0. If it hits 0, I'm going down. It's going to count down from 60 towards 0 until it sees a cycle occur. Different people, I guess different strokes for different folks. Some people like to see this. Some people like to see this. I personally, I like to see how many times or how many seconds between my cycles, because that's how I judge my lubrication rates. Am I over lubing or under lubing? Do I need to make an adjustment there? While we're on this screen and we have room because we don't have that many channels figured, let's set up some startup information. I'm going to go and insert another blank line, but let's set up some startup indicators. So what we're going to do is we're going to create some LEDs on the screen. You saw me delete them earlier. I'll select the control board and all, and here's my startup sequencing. So in my startup process, 3 and 4 are the first part. So we'll select start supply for the first one. Select control again and all. Preloop, LED for the next one. The next thing that was going to happen is it was going to send a driven equipment ready signal. And then the last thing it was going to do was send a start signal. Nothing hard about this. So there are my parameters that I have to satisfy in order to start. My start gas, start supply, my compressor preloop, my driven equipment ready, and my start signal. But I also said in the startup sequencing that I had a skid safety fuel valve, so we could add that in there as well. Let's see, output section, and we're starting that up. We're opening it up at the same time we do the driven equipment ready signal. So what we could do is I could put it on another line, or since it's part of the startup sequencing, how about if I just insert it right here? This will be a digital output, and we'll still call it an LED. Yeah, so there's everything we need to run on that one line. Another thing that we might want to do and might want to monitor is I do believe we set up a fault status. I don't believe we set up a temperature status because we're not using a digital output for a temperature permissive like we would on an older legacy system. Instead, what we're doing on Warmup is we have our temperature status built into the logic, so we don't need to add wires or relays or anything like that. Now, that being said, I don't have to have a digital output assigned to this compressor oil temperature at 70 degrees. If I wanted a visual indication, I could make one. And how I could do that on the HMI is I could go to the channel section and I could go into compressor oil temperature. And I could, if I wanted to again, assign it and make this value match what I did in the startup sequencing. Of course, this kind of becomes a pain to manage too, right? But I could say, hey, let's turn on one of the digital outputs that I'm not using. Let's just select digital output 7 at random. Now, I'm not going to wire anything to this digital output. But I can label digital output 7, RPM or we could call it compressor oil temperature. Well, PRMS for a permissive abbreviation. I think everybody would understand that. So what we're saying, compressor oil temperature reaches 70 degrees, we're going to turn out digital output 7. We've labeled digital output 7 compressor oil temperature permissive. Now, one thing I wanted to point out, and I've talked to the development engineers, and this may happen. Right now, if we select on these digital outputs, we simply have an opportunity to label it. There's been quite a few discussions that what we may have eventually, and I hate to do this, but I think it's important too, and so I think the likelihood of it happening are very important, is for ease of troubleshooting and configuring in the field. There's been talks about building sections down here in this area that show what channel is assigned to controlling this output, which could help a tech out in the field. So the odds are pretty good that that is going to happen. So with that, I can go back to the dashboard if I want, and we'll just drop up here, and I could select an LED digital output, and we'll call it compressor oil temperature permissive. Now, I could have just as easily named this RPM permissive, because here in a minute, I'm going to do something with RPMs too. But there's an LED. Now, if I want to shrink it down and make it the same size as all these, all I have to do is insert a few blank fields. And I pushed them all to the right, all the blank fields, to purposely drive this one LED all the way to the left-hand side. I could have just as easily balanced it and kept it in the center if I wanted to. So that's one way I could have done a permissive. I could have just as easily named this Warmup permissive or anything that I wanted. But now, if I get stuck into the warm-up state, and this is not turned green, then I know that, hey, wait a minute, I got an issue. So that's where the names might become, more important. Maybe in the real world, what I would have done is really named this a warm-up permissive or something like that, just so it would match what we're going to see in the banner later when we run it through a startup sequence. So there's a couple of other things that we can do, and there's kind of an and or in lieu of this. I'm going to select virtual on this last row, and it's going to take me a minute to find them. Oh, hour meter. I always like to put the hour meter up here, so I'll go and grab that. So there's our hour meter. This again is on my demo, and it's got quite a few hours on it. I've been doing a lot of testing. I'm going to go back and select another virtual, so we'll start at hour meter. Don't care about Lube No Flow. We've already done that. Permissive met. I'll select that one. I keep selecting. I got two more I want to do. Timeout. The last one is just simply a timer. So I'll explain what these are real quick. Well, hour meter, I think that's an obvious one. So permissive met, timeout, timer. So the values that can show in this, yes or no. So this is a direct correlation with what we did under the startup. So where we put a permissive, such as Preloop, we have a permissive. So this permissive also, while on the screen, notice I have the timeout timer up here of 1 minute 30 seconds and only 60 seconds for the timer to stay in to this state. So what this timeout's going to show is that timeout timer for the given state that we're in. The timer is going to show the timer of how long we're going to stay into that state. So these three virtual labels that I put on this screen only have to do with what we see on the banner during the startup sequencing. So our startup sequencing. The guys in the field seem to really like this. I really like it because it helps me when I'm troubleshooting stuff too. There's another thing that we can do before we do our startup simulation on this one. Now, today's class is basic, so what I'll do is today is I'll save everything that we did, and then we'll feed in on this and use it for next week when we do a little bit higher level class. But for right now, let's go on and set up speed control based on suction pressure, being that we've configured a suction pressure channel. So I'm going to select this control on the top left, and I'm going to select the channel that I want to base my control off of. And in this case, it's going to be suction pressure. And the output type, do I want it to work as a PID loop, or do I with a single set point, or do I want it to work linear? If I do PID, it's a single set point with a proportional integral and derivative factor. If I do linear, what pressure, suction pressure, do I want a 0% output? What suction pressure do I want right here to equal 100% output? So right now I don't know the full answers to that based on what I've set up for our simulation. So I'm going to save this screen real quick, and I'm just going to bounce back to the dashboard. I can see that my low kill is somewhere up around, looks like 120, maybe 120, or my warning, 125 to 275, I think is what it was. So let's do this. We'll set up an auto speed of 150 to 200. We'll do that. So I'm going to go back into the global. I'm going to enter in just that, 150 for our low and 200 for our high. These are fictitious numbers, but this is just a demo. So I'm saying, hey, put out 0% or 4 milliamps at 150 and less suction pressure. Put out 100% or 20 milliamps at when the suction pressure is equal to or greater than 200 psi. And now I get to select and assign an output channel. If I look back at the drawing for reference, and we'll stay true to the word and follow that interface guide page that I'd set up, I'm using analog output to control speed. So we'll stay true to that one. And again, because I hadn't set a label in the channel section, nothing's showing up. It's blank. So I'll have to go back into the channel section and come down here and give it a name. And I'll just simply name it engine speed, because what I'm going to do is I'm going to use this for both manual speed and automatic speed. I'll show you more. So I'll go back into the global under control, and now when I select channel, it shows up as engine speed AO2 as an option. But right now I'm going to keep my low at 0% and my high at 100%, and I'm always stay with this default ramp rate. It works pretty good. And on speed, I don't want to reverse act it. I guess I could. That's another story next week. But let's do something for fun here. I'm going to assume that what we've done, I'm going to X out of this for a minute. So I have a idle speed, a low RPM, a high RPM, and a max RPM. I also have a way to do auto manual toggle channels, or I have a way to do a manual speed input channel even. But I'm not going to use either one of those for today's demonstration. But what I'm going to do is I'm going to assume that if I send the engine a 4 milliamp signal, it'll go as low as 800 RPM. Now, 3500 by default generally only goes as low as 1000, but most people do go out and program them to where they'll idle at 800. So what I'm going to do is I'm going to tell it in this field 800. I'm going to tell it in this low rated field 1000 because most people don't want to run a 3500 under a load condition under 1000. And then our too high, we'll go on and use the maximum rated RPM of 1400 on both. So this low RPM to high RPM is where we're going to stay at. We're going to stay between these targets based on these pressures. If we put it into manual, we can drive it down as low as 800 though. Same thing. If we wanted to put it in manual and drive it up to 1400, but in auto we wanted to limit it, say to 1350, we could. And this is how we've scaled this. Now this is based on, we're going to send the engine not a voltage signal in this application, we're going to send it a true 4 to 20, unedited. So somebody's probably asking themselves, well, how do you control all this? Well, we got to go back to the dashboard and set up a screen for this one. So what I'm going to do real quick is I'm just going to set up a whole new screen for speed control. And naturally what we'd want to see is we'd probably want to see engine RPM as our primary viewing channel. And then we want to add some controls for it. And that'll be found under the virtual. And so the first thing I want to do is I'm going to select this channel called Auto Manual Bump. Now, that channel is an actual channel where we can manually bump the speed up and down a little bit. And I'm going to pause here for just a minute because I want to show you something. And I actually may have to add a piece of script which we'll finish up next week's class if that's the case. In order to fine-tune that message, and yes, that is the case. So that'll be a parameter that we'll enter in next week on how we can tell it how much to speed up and slow down when we make those changes. So the next thing that I want to do is I want to add another button just like that that has to do with toggling it between auto and manual. All right, so this one's meant to be auto manual bump. This one is also auto manual bump, so obviously I selected the wrong one. Manual speed. Could be the right one. Okay, so now what I'm going to do is I'm going to come down right below both of those. On my auto manual speed, I'm going to tell it, what is it? Is it in manual or auto? And this is where I will confess it gets a little tricky. You might have to bear with me a moment. And I might just have to, there, perfect. That is it. And then we're going to select one more. And I'll explain to you what these are here in a minute. Okay. So this one is a way to bump it up by increments. And generally what I do is I program them. I have to enter a parameter that's covered under script, and we'll cover that next week. But each time I push this arrow button up or down, it'll either speed the unit up manually or slow it down manually, 25 RPMs per push. Some people you can program it to anything you want once we set up that parameter. And this method is a way to where if I want to manually just have a keypad come up and I can tell it go to 800 RPM, I can do that. Now, because it's an auto, it didn't let me change that. And of course, again, I could have selected the wrong one. I told you I might stumble on this section a little bit. So this button toggles it between manual and auto speed. So now that I'm in manual, to test this one, I'll try to change it to 800 RPM again. And it did not let me change, so I may have selected the wrong one. Let's go back and take a look at that. It is an input. It is a virtual channel. And see, this is where I need both of these anyway, so I'll tell you what I'll do. I'll select this one, SP target. I don't think this is it, though. No. We'll come back and try that one more time. I'm going to say that might be it. Maybe I need to be in the running mode. We're fixing to simulate that. So right here in the center, what I'm going to do is I'm going to select SP target and show it as a value. I tell you what we'll do is we'll test this system out right now, and if we need to edit it, we can. That's the beautiful thing about this system. So what I'm going to do is simply reset the system. We don't have any faults. That's good. And we're going to start. So now you can see that the start gas supply and the Preloop did both turn on. You can see that the permissive is satisfied because we definitely have over 10 psi of oil pressure dialed in right now. It's going to time out in 73 seconds and counting, but the timer is going to expire and move it to the next startup state in now 34 seconds and counting. Our compressor oil temperature is above 70 degrees already. So what we're doing is we're waiting for this fuel safety valve to turn on and the driven equipment next. Should happen, and we're counting down. And our driven equipment did, but our fuel safety valve did not. Found that interesting. So let's abort, being that we've already had an issue with our fuel valve not opening, and see what happened. So our fuel safety valve, we told it, fuel safety valve is a discrete, supposed to be energized to open, state 0 is closed, State position 1, no change. No change. State 3, driven equipment. It's supposed to have turned on. Not much of a difference. Let's make a change. Let's say, let's tell it to open here in the preloop state. And see if that works. And it may be one of those things that requires a power cycle. I'm going to spare everybody that for time restraints because we're down to 20 minutes remaining in today's class. Ah, look at there, it came on. So we're going to wait for the 60 seconds to time out. We'll move into a driven equipment ready and then the start signal state. And we can see that we're hung up in the preloop state right now, but we're waiting on this timer. You'll notice our Lube No Flows are setting at a -1. They don't kick in and start working until RPM is detected. Okay, so we're waiting on the engine to crank. So what we can do is assume that, okay, the engine now has started its preloop process. We're continuing to preloop. So I'm going to go on and dial it up a little RPM to simulate the engine cranking. And we can see that the start gas supply valve turned off, our fuel valve remained on, our preloop turned off, our driven equipment ready, and our start signal remained on. We're in the warm-up state. The permissive is satisfied. We know that because of this. And our timer's counting down. Boom. We're in the running state. So the timers for the Lube No Flow work exactly the way I told you. Here we're seeing the cycle time between the lube cycles, holding at about 22 seconds. And here we can see we're counting down from 60 seconds, the fault timer, towards 0. And every time the system resets, it will reset back to 60. So we're in manual speed. And I'm going to try to check out these icons a little bit. And I think what I've got is I've probably got these transposed a little bit. I'll see if I can't straighten this out for you for the full effect of the demonstration. I actually have a cheat sheet that I've been using in my program, so I do apologize. Okay, so my speed target is what my speed thinks it's dialing into. So we'll go on and make sure we get the speed target in the right place where we wanted it. Maybe not. There we go. So manual speed versus speed target. So I just told it 1,000 RPMs. And now that I've told it 1,000 RPMs, it's ramping down to where the analog output is going to simulate 1,000 RPMs. Because I have not put the script in to control this, the speed bump's not going to work yet. We'll cover that next week. I should be able to dial in a setting of 800, and it's not going to let me. So that might be a bug in the system. If I tell it a value of 800 here, oops, now it's going to let me go to 800. Okay. So something for us to improve on that feature right there, because then manually we really want to have full range control of it. So I will report that to engineering. So likewise, if we tell it to go into auto, and we control our own ramp rate, remember I was pointing that out earlier, we can see that it's going to ramp up. And if I wanted to create another icon on this page, and I apologize, I'm kind of making this look sloppy. I could even view the percent output on analog output too. So I can see that 17% equals 905 RPM right now. And if I raise my suction pressure up, maybe what I want to do is just add a suction pressure gauge here so I don't have to flip-flop back and forth from one page to the other. We can watch this speed up a little bit. So what we've done today is we've covered how to set up some channels. Not all of them. I tell you what, while being that I just thought that we hadn't covered all the channels, let me show you one. I'll do channel 2. Let's set one up as a current loop for like a 4 to 20 milliamp pressure transducer. And we'll just call it an example for our channel name. We're going to select a 4 to 20 milliamp pressure transducer. The units we can customize to anything we want. Let's customize this one. Let's make it a pressure channel. So let's say PSIG. We'll do low filters. Let's give it 2 decimal places just so you can see that. 4 to 20 milliamp is the range. Well, for right now it is, but I got to go scale it. So we're going to jump over here and we're going to scale it down here. And I'm going to say that the low equals 0 PSI and the high equals 100 PSI. And it's that simple to set up a channel. So if I come up to the dashboard, there's our pressure channel that we installed. And I don't have my demo set up to simulate the dials on it, but oops, and I've got it scaled 4 to 20, so I messed up. So let me jump back in there and change that. So this first page, and I do apologize, is where I set my pressure range of my pressure sensor. Let's see if we'll take effect now. Yeah, 0 to 100 psi. Now likewise, we can set up these channels be anything we want because they are custom. Apologies, I hit the wrong button. If this was a vibration sensor, like a 0 to 2 inch per second vibration sensor, here's where I could set up the custom units and the custom scaling. So we can really do anything with these things that we want to do. We have a lot of versatility, just like the 3000, but even more. So we've pretty much covered all the channel types that we can set up. We've covered up how to set up the basic system parameters, the DS outputs, the beginning of an automatic suction control, Lube No Flow, we hadn't done trends, parameters, external devices, or script. We'll cover that next week. The startup section. One thing, notice we're running, we cannot access the startup section while the unit is running. Another thing too, on the channels, with RPM, remember it requires a power cycle before any of the changes take effect on this channel. The biggest reason for that was the pulses per revolution. If somebody changed the pulses per revolution, they didn't want to throw the system way out of whack. And so that's one of those reasons why. And we've covered some basic output setup sequencing. So let's test the rest of this as our final test for today. We're going to watch this fuel valve LED and we're going to stop it, which should put us into take us from a running state into a stop state because we didn't activate the cooldown. We should see the start gas supply valve come back open though too as well to test the rest of our program. So I'm going to push stop. And we did see the start gas valve opened up, but I'm a little disappointed we didn't see our fuel valve turn off. And so that's why we test things. So now notice I made that change. All I did was I changed the closed state from standby to the cooldown state. And then immediately when I came back to it, it had turned off. So that's probably the only function that I needed to worry about. I'll tell you what, we've got about 7 minutes. So what I'll do is we'll restart the system and we'll retest that sequencing real quick to see if it works. And at this point too, while I'm doing this and we're all observing together, I'll open up the floor for any questions and answers.
As usual, John, well done. Any questions for Mr. Nance? Exhaustive review here, and as we said here, then session next Friday, we'll take this up one notch here, and we'll cover the more complex, some of the even more complex capabilities and steps that can be taken here to really dial this product in for both the low spec applications all the way and up to the all singing, all dancing panel.
David, can you hear me?
Yes, sir.
David, I got a question for you. Two things. One, for us old guys here, is there any way possible you can go up there and enlarge your screen so our screen is bigger? Is that possible?
I think that's really a function of John's screen. John is projecting.
Yeah, that's okay.
Yeah, so that's I think
There you go. Perfect. Oh, I love it. Now, the second thing, isn't the lube oil, the pre-lube pump supposed to shut off automatically?
Yeah.
Didn't you want it to shut off automatically at 60 seconds? Say that was your time for pre-lubing.
Well, what I like to do on a lot of that, some people do. So some people like to turn on the preloop pump at the beginning of the preloop state, and at the end of the preloop state, they like to turn it off.
Right.
In my case, what I like to do, and what I do in a lot of my applications is I turn it on at the beginning of the preloop state. And once I'm satisfied and met my parameters that I wanted to meet, I keep it running until I need to turn it off. And so in this case, what I do is I don't turn it off, and it just turned off about the time you were asking your question. I don't turn it off until the RPM is greater than 300 RPM.
Oh.
Now, the reason I do that is because if I set a 60-minute preloop timer for the compressor, then I send a start signal to the engine, and the engine's controlling its own preloop and crank cycle, the compressor's continuing to preloop. And some manufacturers will say they want up to a 2-minute preloop time.
Okay, let me get this straight. That 60 seconds that you put in there originally for the preloop, that was for the compressor preloop. We're not talking the engine, right?
Correct. Yeah, because I use an Atom 3 3500 as our example today. So.
Oh, okay. All right. Now I got it. I was off base, sir. I misinterpreted that.
Now, based on that question, though, let's do this. So we've gotten back up into a running state, and let's test that fuel valve safety real quick. I'm going to just push stop, and it did. It turned off immediately.
Yeah.
And you can see that our start gas valve turned back on to supply gas to the engine post-lube sequencing. And we don't know what's going on there because we're not controlling an OEM engine. But let's say we were controlling a old school, let's go with a 3711 Waukesha or old Climax engine as an example.
All right.
So here's the neat thing. We have two permissives. So if I wanted to jump back into the channel section just for real quick fun and set up another pressure channel, and I'll forego some of the formalities, but I'll name this thing real quick. Engine, well, I don't even like that. Engine oil pressure, EOP.
Okay.
Okay. So now I have an oil pressure channel, and it's got real high oil pressure right now. You can see it just ramping up. But what that enables me to do real quick is if I am controlling an old school where I'm controlling everything, dumb engine, not a smart engine, on the preloop, I can put two permissives. So I could select real quick engine oil pressure as my second permissive and say, hey man, you got to be greater than 20 PSI as an example. So now both these permissives have to be satisfied before I'll leave out of this state. And of course I would modify my timers greatly and do things a lot different, but you can see the example. So I can control one preloop for one device or both devices if I want to.
That's cool.
I can turn them on at the same point, but I can monitor them as separate permissives. And if you think about the old systems, we'd throw 5 relays in the panel and have one relay that blocked the next relay to cancel this out and that out just to make sure we got a preloop permissive.
Yeah.
And with this system now, I'm able to eliminate all that. And so no more wiring of LEDs, no more wiring multiple relays and making the panel overcomplicated. I like to do direct connections. And so that makes it really nice for me. And one thing I didn't show today that I also back up about this being able to remove some of that relay logic now is there's a debug section, and it's in this lower right-hand corner. Some people say that looks like a traffic light. Some people say it looks like a little bug. It's meant to look like a little bug, but this is proven awesome out in the field and in the shops for testing products. I'll give you an example. What's the one thing we do when we build a brand new package, when we've just gone through and overhauled the compressor and the engine, and it's something that we're controlling the starter on? It's natural. Like, we want to spin that thing over with the starter first before we ever put any fuel or ignition to it, right? To make sure that nothing's bumping. How many times, somebody might set their strike and clearance wrong on one of the compressor throws or something like that. Well, what we have the abilities to do here is we can go into this debug page, and we can only access this debug page while the unit is down. But we can force outputs on and off. So example, if I want to test the Preloop, I can turn on and off DS output 4. And I've already had some amazing troubleshooting episodes happen in the field because of that one feature right there. I was in a shop a while back, and it was a 3300 engine, small engine, but it was a old school. It had a Ultronic 5 magneto on it. And they said, yeah, can we bump check it? And I said, sure, man, stand clear. And boom, we had DS3 controlling the starter directly. So we were able just to engage the starter with no ignition or no fuel. And for troubleshooting purposes, if we're doing logic with these digital outputs, it's the same thing. And if you have more than one terminal board, you can toggle from terminal board 1 to terminal board 2. I was just in a shop yesterday doing this, where I had multiple digital outputs and DS outputs forced on at one time, just for testing purposes in a shop. So this has been a huge, huge feature already.
And they're not bumping heads with each other. You can actually do it.
Yep. Yes, sir. Like I said, I thought I liked the DE-4000, but I love the 4000. From a mechanical, out in the field troubleshooting perspective, it's great.
Real quick question, David. Did you say, and I'll get off the line, did you say you're working on getting the recordings on these?
Yeah, that's right. We're in the process of, we've collected all the recordings. As a matter of fact, this one as well. So we'll be adding that to the list. And as I said, we're going through all the IT issues related with Herbiger, which, as I'm sure everybody can imagine, is significant with a larger company.
All right.
Once we get that sorted out here, we should we'll send a note out, as standard distributor note out to everyone as to how to access those. So so that's the plan, so that we would have some good offline capability.